Alright, let's continue. Numbers 2 through 5 actually all regard the same systems. We have to tell whether each ordered pair is a solution of y is less than 2x plus 5, and then, along with that, 4y is greater than negative 4x minus 8. And they give us these 4 different points, and they want us to determine whether or not these points are solutions for the systems of linear inequalities now. What's the best way to do this? Well, you could plug in these points, 1, 2, 0, 6, negative 1, negative 2, and negative 1, 2. You could plug each of these points into these equations. Y is less than 2x plus 5. 4y is greater than negative 4x minus 8. And so if you plug in 1, 2 here, 1 for x, 2 for y, you come up with a true statement, then this would be true. If you come up with a false statement, it's false, meaning it's not an ordered pair. It's not a solution. But you have to check each one. There's an easier way, however. There's an easier way to accomplish this task. And that is, when it comes to solving inequalities, we're better off making a graph. And that's because our solution set for an inequality has a range. It has more values than just one point of intersection. Alright, let's begin. Let's graph y is less than 2x plus 5. Looking at this as a regular equation, we know this is a slope of 2 and a y-intercept of 5. We can go over that another time about how I know exactly that 0, 5 is one of the points on this graph. But for now, I'm going to assume you understand y equals mx plus b. And we're going to continue. So, first point here, 0, 5, slope of 2, up 2, over 1. Grab a ruler. Let's go ahead. We're making a dotted line. A dotted line because this is an inequality. And this here is y is less than 2x plus 5. So this point 0, 5 is not part of our solution set. This point here, let's see, what is that? 1, 7? That is not part of our solution set. However, everything below this line, everything down here, which I'll shade it in a moment, is a part of our solution set. I'm going to wait to shade it all in because I want to also graph the next line. 4y is greater than negative 4x minus 8. Let's tidy this up a little bit. I noticed that we have this 4 here. We have 4x minus 8. Everything here is divisible by 4. So let's just divide this by 4 and divide everything on the other side of the equation by 4. Remember, equations, you can just do whatever you want to them as long as you do the same thing to both sides, as long as you don't divide by 0. An equation is a thing that you can play with and turn into something to make it easier to look at for you. And that's exactly what we're going to do here. 4y divided by 4 is just y. And that is going to be greater than, well, let's see, negative 4x divided by 4 is negative x. And then negative 8 divided by 4, well, that's just negative 2. Very good. Y is greater than negative x minus 2. Okay. Let's go ahead and start plotting this. We have a y-intercept for this one of negative 2, so we're going to come over here. 1, 2, and I wish I had a different color marker, but we do not, so we'll have to make do with what we have. We have a negative slope here. That means that our graph is going to, our line is going to point this way. Rise over run of 1 over 1. 1, 1. Again, a dotted line. And there we have it. Where is our solution set for this problem? Well, it's everything above the line. everything in here is a solution set for this line. Where's our solution set for this one? Well, it's everything below this line. So everything in here. So everything in this area, this infinite area to the right, is a solution. Let's go back to our 4 options for numbers 2, 3, 4, and 5. Is 1, 2 part of the solution set? Sure is. That's easy to see. Check, that's true. Number 3, is 0, 6, 0, 1, 2, 3, 4, 5, 6, is that part of the solution set? No, it's not inside this area over here. That is not true. -1, -2, is that inside? No, it's outside. It's not part of the solution set. Not true. Lastly, -1, +2, 1, 2. That is in this area. That is true. Now, I just want to make one thing clear. It may seem like we went a little out of our way from looking at these problems in order to solve this equation, but we've saved ourselves a ton of time, because if we went through and plugged each of these into each of these, that would be 8 different problems to simplify, 8 chances to make a mistake. Here, you just graph the 2 lines, and you see where these points fall. The only way, you have to know how to graph, of course. You have to make sure that your graphs are set up properly, and you have to make sure that they are not skewed, not misaligned. But if you do it neatly, and you do it like this, you can easily determine whether or not an ordered pair is a solution of a system.